Right, so here are the notes for day 2. We are going to be looking at a numerical approach, which just means that we're looking at data from a table. So it says the table below shows ordered pairs on the graph of a function f of x that consists of line segments connecting the points in the table. Use the table to create a table of values for each function below that is a transformation of the graph. So here is our original f of x function. And now we have a change to the graph. So if we look, we are dealing with stuff on the outside. So this is going to be a reflection against the x-axis, and then we're going to go up 2. Again, just making sure that we read the directions. State the shifts and or reflections that f of x undergoes to obtain the graph of g of x. State what the changes are made to which coordinates of f of x to obtain the coordinates of point. I need to fix the language here, but basically this is what it's saying. We're going to state the coordinates, reflect x-axis, and go up 2. So the coordinates on the f function, the x coordinates, or at least take take 2. All right, so here we are utilizing day 2 notes. It says the take 3. All right, here we are with day 2 notes. It says that the table below shows ordered pairs on the graph of a function f of x that consists of line segments connecting the points to the table. Use the table to create a table of values for each function below that is a transformation of the graph of f of x. So let's take a look at what this is saying. So what we're going to do, remember, we're going to circle our verbs and underline important information. So let's read it once. State the shifts and or reflections that f of x undergoes to obtain the graph of g of x, stating what changes are made to which coordinates of f of x to obtain the coordinates of the points for g of x. All right, so basically we need to create a new table of values for g of x. So we're going to have to state the shifts and or reflections that that is affected by f of x, and then we need to state the changes to the coordinates. All right, so let's take a look. You can see that this table is the coordinates right here. So all that we did was take the table and put them in ordered pairs. Now we need to identify the shifts and reflections. So the first thing, when you identify some things, please do them in order from like left to right, just so that we're consistent. I'm highlighting them both yellow because they're both on the outside. So the first negative is going to reflect the x-axis, and then this positive 2 means that we're going to go up 2, which means there are no changes to the x value itself, but we do have 2 changes to every y. So we're going to have to multiply the y value by a -1, and then we are going to have to add 2. And that's how each one of these coordinates are changing. So all of these x's stay the same because we're not changing them. So we've got -3, -1, 1, 3, and 5. The changes to the y coordinates. Well, we're supposed to go the opposite of y, and then we're going to add 2. I recommend that you organize your points. Don't go too fast. You don't want to make a mistake. We're going to go back and we're going to plug in our y values. So 5 goes here, 1 goes here, -4 goes here, 1, and then 2. And then we're just using our algebra here. We've got -3, we've got 1, we've got 6, 1, and 0. And then this is going to generate our new ordered pairs, which would be -3, -3, -1, 1, 1, 6, 3, 1, and 5, 0. We're going to try the same thing on number 2. Again, by the way, when you're done, go back. Did you state the shifts and reflections? Yes. Mark it off. Did you state the changes to the coordinates? Now we're done. Here we go. Again, we're going to do the same thing. We're going to state the shifts and reflections. We're going to state which changes are made to the coordinates so that we could generate the new ordered pairs. So I like to highlight the outside in a specific color and the inside in a specific color. And then I like to organize them in order from left to right. So number 1, a vertical stretch by a factor of 3. Number 2, remember what we want to do. We want to take whatever's on the inside, set it equal to 0. We get x is equal to -2, which means we are going left 2. Whatever's on the outside, we're just going to now go down 3. So the only one that's affecting the x coordinate is this one, which means I am going to end up subtracting 2. So I take my x coordinate and now I'm going to subtract 2 to that. And then on my y, I'm going to be multiplying my y by 3. And then I'm going to subtract 3. So changes on the x coordinate. All of these are my x's, and I'm going to subtract 2. So I've got -3, -1, 1, 3, 5, and then I'm going to subtract 2. That's going to give me a -5, a -3, -1, 1, and 3. Changes to the y, 3 times y minus 3. Again, I'm just organizing my table. And then now what I'm going to do is take and plug in my y values, 5, 1, -4, 1, and 2. And then now I'm going to generate, just simplifying, 12, 0, -15, 0, 3, creating the new coordinates. If there's any confusion, please let me know. Let's go to the next page. Let's take a look. Again, highlighting any changes in one color that affect the y, and then these affect the x. Notice that you have a negative. Please factor out the negative. Q of x is equal to f, and then this whole thing would be in parentheses and then -2. Reason being is that way people, if you don't factor out a negative, you end up getting the shift wrong. So the first thing is we are going to reflect against the y-axis. Then we are going to shift right 3. You're setting this equal to 0 and solving. And then we are now going to go down 2. The changes into the x, you have to do multiplication before addition. So your shifts are always going to be at the end. So reflections are always multiplication. So I'm going to reflect the x, right, against the y-axis. So it's a -x and then +3 to move right 3. And then down 2 is just y minus 2. So again, we're going to go -x plus 3. Again, any questions, please ask. Now we're going to take the y value and subtract 2. So I'm just going to take my y's and subtract 2. Getting everything set up. This is my x, -3, -1, 1, 3, 5. And so we end up getting here 6, 4, 2, 0, -2, 3, -1, -6, -1, 0, in the ordered pair. Okay. All right, now this is a new topic. We're talking about graphs of piecewise functions. This might be relatively new to you, and if not, great, just let's make sure that we can follow through. Number one, always look at given domain. All right, so we need to look at the given domain, and then we're going to use that information to create a table of values. Okay, so create a table of values based on your domain. Make sure to include open or closed endpoints. Okay, so for example, I need to make sure that I include my table of values for this function. So let's take a look at the actual function here. Do this. So the function is x minus 2 squared minus 3. My table of values need to begin at -1. Because it is not equal to, it means it's going to be open. And I need to have the x values from -1 all the way to +4. So -1, 0, 1, 2, 3, and 4. Now, sometimes it's not necessary to generate everything, but when you have an interval that's specified, it's better to be safe than sorry. So now I'm just going to evaluate. So I'm going to have, instead of x, I'm going to plug in -1 minus 2 squared minus 3. This gives me -3 squared is 9 minus 3 is 6. So I have the point -1, 6, and it's open. 0. 0 minus 2 squared is going to be 4 minus 3 is going to be 1. 1 minus 2 is -1 squared is 1 minus 3 is -2. So when x is 1, I get -2. You also should recognize with your transformations that the vertex is shifted to the right 2 and down 3. So if I were to plug in 2, that gives me 0 squared, which is 0 minus 3 is -3. And there's the vertex. So really, I should have, with my knowledge of parabolas, be able to generate the next couple of points. But people tend to forget and they draw arrows. And it's not going to be arrows because it stops when x is 4. So 3 minus 2 squared is 1. Squared is 1 minus 3 is -2. And then the last point, this is going to give me 4 minus 3, which is 1. Notice that it includes the point 4. So this needs to be closed. Okay. Everything else in the middle is always going to be closed. The only thing that would be open would be the endpoints. So I'm going to go 3, -2, and then 4, 1. And then I'm just going to connect, stop, and then connect and stop. So there's that portion of the parabola. Now I'm going to do the same thing with my line. Okay, so I've got 2/3 x plus 2. On my table of values, I need to start at 4. It's open. So I've got 2/3 times 4/1 plus 2. That gives me 8/3 plus, in order to add fractions, I need to get common denominators. Common denominators 3, which makes 2 the same thing as 6/3. If I'm graphing 14/3, I really need to make sense of that number. 3 goes into 14 4 times with 2 left over. So I'm going to graph the point 4 and 4 and 2/3. So 4 and 4 and 2/3, and it's open. So it's not exactly on the line, but it's pretty close. The next point that I want to pick, because I don't want to have to deal with fractions, is going to be any multiple of the denominator that fits within the domain. Remember, we are allowed to have only x values that are bigger than 4. So I'm going to pick 6. So I've got 2/3 of 6 over 1 plus 2. Well, when I simplify that, 3 goes into 3 once, 3 goes into 6 twice. So I get 4 plus 2, which is 6. So 6, 6. Now, this goes on to infinity. I can utilize the slope up to over 3, up to over 3, and then just connect them. Okay. Then I would like us to practice our domains. Let's take a look at the domain on this one. The domain starts at -1 and it goes until we have got an issue at 4. The x value does exist at 4, so we don't stop. We pick back up on the other side of 4 and go to infinity. Infinity will always have brackets. The question is -1 opened or closed? If it's open, it's a parenthesis. So there's our domain, and let's look at our range. The smallest y value is -3, and it includes -3. We go up at 1, all right, still going up, 6. According to this 6 doesn't exist right here, but this one does at 6, and we keep going up on our y values, so there's no break in the range. All right, so I would like you to try this one, number 2.